everyone. Today, myself Swati Babulwad. Today, I am going to represent asset properties of transaction. Let's start. First, we take up outlines: transaction concept, transaction state, concurrent exclusions, serializability, recoverability, implementation of isolation, transaction definition in SQL, testing of serializability. So, transaction concept. A transaction is a unit of a program execution that assesses and possibility updates various data items. Example: transaction to transfer $50 from account A to account B. First of all, read A, then assign the values of A minus 15A, then write A, read B, and we add the values of B plus 15 in B and then write B. Two main issues to deal with: failures of various kinds such as hardware failure and the system crashes, concurrent execution of multiple transactions. Asset properties. A transaction is a unit of program execution that assesses and possibly updates various data items to preserve the integrity of a data. The database system must ensure atomicity. Either all operations of the transaction are properly reflected in a database or none are. The second one is consistency. Execution of a transaction in isolation preserves the consistency of a database. Third of all, isolation. Although multiple transactions may execute concurrently, each transaction must be unaware of other concurrently executing transactions. Intermediate transaction results must be hidden from other concurrently executed transactions. That is, for every pair of transactions Ti and Tj, it appears to Tj that either Tj finished the execution before Ti started or Tj started execution after Tj finished. Then, durability. After a transaction completes successfully, the changes it has made to the database persist even if there are system failures. Then we look up this transaction state. Active. The initial state, this transaction stays in a state while it is in execution. Partially committed. After the final statement has been executed. Failed. After the discovery that normal execution can no longer proceed. Aborted. After the transaction has been rolled back and the database restored to its state prior to the start of a transaction. Two options after it has been aborted. Restart the transaction can be done only if no internal logical error. Kill the transaction. Committed after successful completion. Then we look up transaction set. This is an active, partially committed, then committed, failed, and aborted. Concurrent execution. Multiple transactions are allowed to run concurrently in the system, such as advantage are increased processor and disk utilization, leading to better transaction throughput. Example: one transaction can be using the CPU while another is reading from or writing to the disk. Reduced average response time for transactions. Short transactions need not wait behind long ones. Concurrency control schemes. Mechanisms to achieve isolation, that is, to control the interactions among the concurrent transactions in order to prevent them from destroying the consistency of the database. We study afterwards. Then schedules. A sequence of instructions that specify the chronological order in which instructions of concurrent transactions are executed. A schedule for a set of transactions must consist of all instructions of those transactions. Must preserve the order in which the instructions appear in each individual transaction. A transaction that successfully completes the execution will have a commit instruction as a last statement. By default, transaction assumed to execute commit instruction as its last statement. A transaction that fails to successfully complete its execution will have a abort instruction as the last statement. Basic assumption. Each transaction preserves database consistency. The serial execution of a set of transactions preserves database consistency. A schedule is serializable if it is equivalent to the serial schedule. Different forms of schedule equivalent give rise to the notions of complete serializability, view serializability. Simplified view of transaction. We ignore operations other than read and write instruction. We assume that transaction may perform arbitrary computations on data in local buffers in between reads and writes. Our specified schedule consists of only read and write instructions. If a schedule S can be transformed into schedule S by a series of swaps on complete instructions, we say that S and S are complete equivalent. We we say that schedule S is complete serializable if it is complete equivalent to serial schedule. Some applications are willing to live with a weak level of consistency, allowing schedules that are not serializable. Example, a read-only transaction that wants to get an approximate total balance of all accounts. Example, database stations computed for query optimization can be approximate. Such transaction need not be serializable with respect to other transactions. Trade-off accuracy for performance. Transaction definition in SQL. Data manipulation language must include a construct for specifying the set of actions that comprise a transaction. In SQL, a transaction begins implicitly. A transaction in SQL ends by commit work, commit current transaction and begins a new one. Rollback work causes current transaction in abort. In almost all database systems, by default, every SQL statement also commit implicitly if it executes successfully. Implicit commit can be turned off by a database directive. Example, in JDBC connection, set auto commit false. Thank you.